Hello everyone, my name is Gil, and I'm a backend developer on the mobile delivery team in ironSource. Today I want to share with you the journey we made in the past couple of years and why and how we end up choosing Aerospike for our mission-critical path in our ad delivery system. So let's talk briefly about ironSource, who we are, and what we offer to our clients. ironSource is a monetization company based in Tel Aviv, and our core business enables publishers to monetize their app by running ads while allow advertisers to increase their user acquisition rate. Here are some interesting numbers about ironSource. We established in 2010. ironSource now has 750 employees in 8 branches around the globe, when most of the R&D team located in Tel Aviv. We are reaching out to 2.3 billion people a month, and our monetization platform leads to more than 4,000 installs per minute. Our mobile department focuses on casual gaming market. We have several products, such as rewarded video, which allow the publisher to play a short video ad and reward the user for it. Let's see a really short video that demonstrates this product.
Wide. Today, the world of in-game advertising is mainly driven by rewarded video. Rewarded video lets users who need additional in-game currency either pay for an in-app purchase or watch an ironSource video ad. Advertisers get in front of engaged users and only pay if users actively choose to install. And publishers earn revenue while delivering a well-balanced experience. This is a unique ad unit which is initiated by the user and infuses advertising into the game's economy. In addition to being an advertising marketplace, ironSource is also a leading monetization platform, controlling all major ad networks while allowing developers to manage their ads in one place and maximize revenue. That means even if a user sees an ad, such as a rewarded video delivered by Facebook or Google's ad networks, it's the ironSource platform driving that value exchange. The ironSource platform powers next-generation advertising by connecting game developers and advertisers with billions of users worldwide at a point when they're actively consuming digital content.
Okay, no more marketing slides. So let's talk about what is it that we actually do and how it's related for this summit. So this is our tech stack. Let's go over it very quickly. Aerospike, of course. Redis was our first choice of in-memory key-value database, currently used only for low-scale use cases. MySQL is our relational database for supply and demand management system, and Cassandra is our NoSQL offline storage solution for a large volume of data. Scala is our primary programming language, and Ruby is programming language for our QA automation system. We based on HashiCorp products. Our infra is based on several of Hashi products, Consul for service management, and Nomad for resource allocation in the cloud. AWS is our cloud provider for server, big data storage, and a lot more. And we use Kafka for service communication, and Akka is our stream processing library. Okay. I choose a small part of our delivery system to demonstrate what we do. ironSource has millions of mobile devices that run our SDK. Each time a user opens an app, our SDK make a request for our ad server and receive a number of ads. This process involves multiple internal services and will provide the SDK a list of most relevant ads, meaning the user is most likely to interact with them. 2 key internal services in this process are the data science service, which use machine learning model to provide the right ads for the right user, and the user counter service, which filters the ads the user already saw. Once the user saw the ad, our data pipeline receives events that indicate the interaction the user made with the ad. And in a good scenario, the user will view the ad, following by a click, and then install the advertiser bundle. Each of these events is propagated to a multiple service, including third-party tracking companies, to validate and measure the performance of the campaign. Okay. Now let's talk about one of the services that rely greatly on key-value storage on a large scale, the user counter service. To avoid showing our user the same ad too many times, we want to keep counters for all delivery campaigns per specific user in different time span, for example, hourly or daily. Obviously, this is a mission-critical service for our system. It's a part of our online flow, meaning the user or even an RTB exchange server is waiting for our reply, and we have to answer as quickly as possible, less than 100 milliseconds. High latency or even worse, downtime of this service could cause us to over-deliver all of our campaign and lead to immediate revenue loss. In terms of scale, we are talking about 100,000 IOPS for reads and 70,000 IOPS for write, and 5 kilobytes for every object on average, and totally 60 gigabytes of data for this data set. Because business growth is tightly coupled with this database, we need to be able to scale up quickly. Let's see the solution we found for this use case. So we start with Redis. For those of you who aren't familiar with Redis, it's the in-memory NoSQL database. Redis themselves actually call it in-memory data structure store, and I think it's a good selling point. Their API is command-oriented. There is no SQL queries that operate on different data structure, very similar to the way developers think and write code. But in our experience with Redis, we are faced with two issues. One, the Redis cluster was hard to play with. Redis, at least back then, didn't have a real cluster solution. So we need to deal with stuff like sharding, like key sharding and data partitioning in our end and code base. Secondly, and most importantly, very fast we reached a point Redis just couldn't scale up and meet our demands. We couldn't add any more IOPS and storage, and our DevOps team effort to support the cluster was becoming overbearing. So we need something else, and we start to test another databases. So we moved to Aerospike. The migration process was relatively easy. We found that the Aerospike API is also very intuitive for developers. And the support of CDTs and UDF allows us to maintain the same data stream and architecture that we already had with Redis. The scale and stability issue were the main reason for the migration, and very quickly we managed to stabilize the system and achieve our performance goal. So currently we reach 130,000 reads and 75,000 writes with 15 instances. We have an uptime of almost 100%, and most of our queries is less than 1 millisecond. Aside from solving the performance issue, the migration reduced dramatically the time spent by the DevOps team to support and maintain the cluster. And this is a real quote from one of our DevOps team members when I asked him about Aerospike cluster feedback for this talk. And finally, and most importantly, improving performance and scale allow us to add more counters and time dimension, and give our advertiser more accurate campaign delivery and capping option, which is a clear business advantage. So I already mentioned the Aerospike API and the support of CDTs. I would like to give a brief example of what we did with CDT API and how it helped us to gain the performance boost we needed. In the delivery process, we need to limit the number of times the user sees a specific ad or campaign in a different time frame, hourly, daily, or lifetime. Our solution is to use a map in the following way. For each user, the primary key, we store a map with the campaign ID as the map key and the counter for the number of views or impression or any other event as the map value. The write operation is made with the native map operation, so we know they are atomic. We can now get all the capping data for a request user in one read. We model the time frame, hourly, daily, with ETL, so each time frame has its own set inside our namespace. A similar thing is done with the bundle separation. We don't wish to show the user ads for already installed apps. We store for each user a list of all apps we know he or she already installed. Again, the add operation on the list is atomic due to the native operation, and we can get the whole list in one fast read. So let's sum up all the advantage we talked about so far. Data modeling, CDT and UDF. CDT support is great, and we use UDF when we can't find the right native operation, but we still want to get atomic update for our multi-threaded environments. The support of CDT together with multiple beans per key with the different data types allow us to design simple data stream with strong performance. Fast onboarding. The Java driver, together with our own adoption of the community-driven open source Scala wrapper, and with detailed documentation help us to build our data store software layer relatively fast. Of course, this is our primary goal, scale, and with the right data stream, and we always get what we need from Aerospike. Maintenance. Some of the feedback that I got from our DevOps team is the time and effort to set up a new cluster or support and maintain the existing ones is relatively low compared to other data storage products they have under their responsibilities. Also, the scan command is a nice feature worth mentioning. We use it a lot when we need to migrate data from set to set or change already written data and fit it in a new scheme. Apart from good documentation that can be found online, our local distributor is an excellent source for support. And when needed, it provides us a direct channel to the Aerospike R&D team here in the state. Okay, so let's talk about SOR and how we see it. Let's rewind for a second to what I showed you at the beginning of the presentation. After delivering the campaign to a user, we start getting events for each interaction with the ad. It could be a click, impression, or any other event. All of these events arrived in numerous ways to our data pipeline. Some directly from our SDK, some from system of our publisher, and some from different tracking companies. The data that we receive is partial, with different IDs and because of the different source. We keep most of this data in a relational database in AWS, like Redshift, but we store the key facts of this data, such as install date, or in-app purchase transaction in our Aerospike engagement cluster for later use. In order for us to understand the meaning of this event and link them to events that precede them in the system, we also keep partial facts about previous stage in the process on the Cassandra cluster, our request record cluster in Cassandra. And to support this kind of scale in Cassandra, we had to separate the tables into weekly tables. Otherwise, the compaction of the table would take too long and to be too expensive. On top of all that, all this data was sent to an event stream based to our data science service because it's a key ingredient in their forecast models. This legacy architecture that was created over the years becomes scattered and complex topology. To get a full view about a transaction, we had to query Serval database and Aerospike set, and sometimes even go to a slow relational database like Redshift. This legacy infra became a technical burden and holding us back. A change was needed, and thought we were not familiar with SOR concept back then. We came up to a solution that's quite resilient, quite similar. Okay, so we took all the small user engagement database that were scattered in the system and combined them with a partial fact data that we already had in Cassandra. And then remodeled all of this data to a new compound data element containing all the data about a single transaction from the first initial request that our SDK makes till the user installs the app or any other campaign goal. As you can already tell, we choose Aerospike for this mission. The scheme Aerospike provides fitted with our initial design. Every stage in the process enters into its own bin so that writing of one stage doesn't require locking and doesn't distribute writing or reading of other stages. Each bin contains all the data in JSON format and then compressed in a protobuf to save storage and network bandwidth. This data service, which we called funnel data, is designed to be an exclusive source for information about all live transactions, or in other words, a single source of truth, a key concept of the SOR paradigm. We are currently in advanced migration stage. Once the migration will be complete, we plan to connecting this service to additional supporting systems, especially the data science service, which till now had to rely on event-based stream and had to query an additional database to retrieve the full transaction information. So, why we choose Aerospike for this new infrastructure? We are talking about mission-critical service that a lot of points in our system will be rely on and can very quickly become a single point of failure. Fortunately, we have a long and good history with Aerospike when it comes to performance and stability. Also, a product that is well-known to both the developers and DevOps team has a major advantage and give us the confidence in implementing this solution. Currently, our SOR scale requirements are pretty modest, less than 1 terabyte. But as soon as we start to add more in-house customers to this record database, we are expected to grow significantly. And also, I don't have the exact numbers, but it's my understanding that Aerospike offers special license for SOR system, which substantially decrease cost. Okay. Business advantage with SOR. The concept of single source of truth is simplified our system, meaning developer new business feature is now more faster than ever. We can now reflect more comprehensive data to our supporting system, especially our data science team, or the BI platform. Consolidating multiple database to a single database cut down the cost of infrastructure and licensing, and long-term storage in SOR may decrease future spending on relational database. Okay. That was short. Any question? Thank you. Yeah.
How do you, can you talk about your reporting side of things? Dashboarding, how do you, with your SOR, how do you do that?
Currently the SOR is only for the offline system, but all our reporting in BI done with the relational database in Redshift.
Can you repeat the question after she asked?
Okay.
Are you still using Redis and Cassandra, or did you migrate off?
No, Redis only used for a very low, if we still use Redis and Cassandra. So we are not using Redis. We have one legacy database for Redis, and we hope we will get rid of it next year. And we are currently use Cassandra, but we are checking Aerospike or any other optional database.
So, sliding that offline DB.
Yeah.
How do you write data to offline DB, and do you use the offline DB as a ER?
Here. We have Kafka that can read and write.
Can you repeat the question?
How we write, how we get from the final data to our offline DB in production. We have Kafka, so we have a consumer that read from the Aerospike cluster and then send it via HTTP to Redshift.
Okay. So does the application write to Kafka, or the Aerospike write the log to Kafka?
Yeah. We read from the final data from Aerospike and then push it back. It's a consumer producer topology. Okay. Yeah.
So how are you guys deploying that? Are you using EC2 instances or is
EC2, AWS.
VMs or like Docker container?
We have Dockers and a Nomad that is a HashiCorp like Kubernetes solution for services. So we run it all in Nomad.
A follow-up question about the offline DB. So if you use the Aerospike as a SOR, what do you use the offline DB for?
Repeat that question.
Yeah. If we use Aerospike as a SOR, why we have an offline DB? So currently, we have a very big offline DB that's used by the BI guys and reporting and all other departments. So we hope that in the future we can remove some of this information and store it only on the final database. Okay. Thank you very much.